Okay, so this is a brief introduction on the Lab 2. Lab 2, you will have two tasks again, but the Lab 2 total marks is 10 marks just for the lab, so it will be effectively 7.5 marks when you take the total score for the subject. Now the first part here, so what you need to do is first get the iLearn, go to iLearn, get the lab from the iLearn. So that should appear here, Lab 2, and you will also see there's a Lab 2 quiz. So that Lab 2 quiz is the task 2 of this lab, which you need to do during the lab towards the end. So if you go to Lab 2, you will see 3 files. So you need to download lab2.emp and lab2 worksheet. Now PDK installation is an extra file. In case if you are doing it in your own laptop and you don't have the right PDK, you need to download the PDK and then install that in your laptop as well. But in the lab PCs, there's already lab PDK installed, so you just have to download the lab2 and then start following the instructions. Now when you download the lab2 worksheet, you'll notice there's the first task is to do the lab and the second task is to do the quiz. So the lab is a group exercise. If you decide to do it in groups of 2, that's fine, or group of 2 is preferred. Group of 3, we'll have to talk to the tutor if you want to do groups of 3 if there's so many people in the lab. Otherwise you can do it individually as well. When you do the lab, you have 3 questions to answer during the lab. That's a task 1, so that can be done as a group. The task 2, which is the MCQ, there are 5 MCQs, multiple choice questions, and they are on iLearn, and you'll get 10 minutes in total. So you have to do that individually. Remember, it's individually, so if you can only do it within this lab duration. So if you missed it, you won't get marks for that. So remember, you although you work in a group, this lab quiz has to be done individually, so because everyone will get marks, individual marks for it. So it's only 5 questions. I recommend to do that lab quiz towards the end of the lab, maybe in the last half an hour, or once you finish your lab first 3 questions. So this lab shouldn't take you whole 2 hours. It should quite be straightforward. Now in the lab, when you open up the AWR project, you will see on the left hand side project window things under circuit schematics. So that circuit schematic, if anything under circuit schematics, will be the circuits that is used in the lab, and there's few graphs. Okay, so we'll go through the graphs quickly. Before that, so the question 1 is in create an IV curve graph. So what you do is you go get the IV curve. You'll see something's already populated, but if you don't have one, you just do analyze, click the analyze button here. Now if you see into the graph, you'll see it's done for, so this should be, there's a typo in that, so maybe I can just change it now, 2 by 25, that's what it says, not 2 by 5. Or you can just run it again, it will just populate the same thing. So it's IV curves. So this is you must have done and current and the voltage curves for any transistor. Depending on your biasing, you'll have different IV curves. Now the setup for IV curves is taken from the circuit schematic. So you have a transistor, and then you have different parameters, number of fingers, UGW, unit gate width, and then the temperature and the noise, and this gives set up a sweep. So this is a setup, but this is done for 2 by 25. Now when I say 2 by 25, it says number of fingers is 2, unit gate width is 25. So you can always look at the help file and then look at these parameters, what it means. So I suggest you to do it, because the MCQs, when you do the MCQs, you'll need to know what these means, enough and this is not where it should be, maybe it's something, but you should be able to look at the help file. It's not coming up in my PC for some reason, but it should pop up. Now to briefly clarify this, so if you have the normal setup, a transistor will have its gate, and it will have a source, it will have a drain. So basically you form the channel in between that. So the gate triggers whether the channel is on or not. But so just like a very quick recap on what you've done like earlier in your last courses, probably 3076 or 676, whatever it is, or your undergraduate degree if you're a master student. So whatever you apply for the gate, depending on your bias, you let the current flow. Now this is the length of the channel, and this gate, if you look at 3D, you will have something like that. So that is called the width. So it's not conventional, because normally you would tend to say this is the width. This is normally the tradition is that to be the width, but in transistor term it is the length, and the width is. Now for each source and drain you have one gate. So source is normally grounded through a VR, and the drain is connected to the supply. This width is, in this case, when you have a 2 by 25, width is 25 micrometer. That's what it means. Now when you say 2, it means how many gates do we have, how many fingers. So each gate like that, we call it a gate finger. So if you have 2 of them, so if I write it here, you have a gate, then you have a source, you have a drain, then you have a source, and you have a drain. So if you have 2 of them, so that's one transistor, and that's another transistor. So you have 2 gates, so we can say 2 by 25. In practice, so you see this is the source and the drain and this source. You don't do it like that. You do, so pretty much flip this. So you have a drain here, you have a source here, then you combine the drains. So you have source, drain, source. So what you effectively will have is source, drain, and a source. And then you have the gates. So you have two gates, and each of them would have a width of 25, 2 by 25. So that's what it means. So in your question, it's asking you to create IV curve graph for 2 by 50. So same way like this, you need to create another schematic for a 2 by 50. So basically you just go in here, create new schematic, go follow the prompt, do something very similar to IV curve 2 by 25, but replace this with the 2 by 50. So that's question 1, and then you need to show these results to the tutor once you finish that, and you get 1 mark if you complete that. Then they create a gain comparison chart for 2 by 50 similar to 2 by 25. So there is already a gain chart for 2 by 25 that shows with the frequency what is your gain. Now that's taking the schematic from here, 2 by 25, and it's already set up. So this is a bias T. So what happens, this is a transistor 2 by 25 as before. So the bias T basically provides you the RF and the DC both. Normally when you use a transistor you need to bias it, so but you can't bias it through the RF. So the setup we use is called bias T. So it has a RF input and a DC input, and combines RF and DC and give it to the gate terminal. The same way you can use it as source terminal. So you need to create a similar setup for this, like this, for a 2 by 50 transistor, and then you can plot. So you create another schematic same way for 2 by 50, and then you can add that plot to this graph, and then you can create the comparison chart. So that's question 2. Question 3 is you will have a tune the LNA circuit component so that it can meet the spec. So that's a LNA circuit. If you see, there are 3 components. So this is input match, intermediate match, and the output match. So there are 2 transistors, one 2 by 25, one 2 by 50. So you have, this is a 2-stage transistor. In input match, if you go inside, you can use this arrow here, go inside, you'll see the circuit used in there. So it's pretty much a capacitor. So when you have a RF input, you have a capacitor to isolate the DC coming from this side, and this also forms a part of the matching circuit. And this capacitor also provides the electrostatic discharge sort of ESD protection as well, because this fuses, acts like a fuse. Now that doesn't matter, the matching circuit we'll learn more, but this is a matching circuit that we use. You don't have to know exactly what each of these components, like this is an inductor, this is a capacitor. So these are capacitors and inductors are passive devices, so they are not active, which means they don't need a voltage or current to bias them initially. Now you have that is the input match. If you go up, the similar intermediate match you have, that's the drain. This provides the bias, and this provides the bias. So you don't need to know the details, but what you need to know is you have to so you'll see some things are blue here. So the C is blue, L is blue, W is blue. That means these are tunable. So if you want to make something tunable, you can use this tuning tool, click that, and then go and click what you want to tune, and it becomes blue. Now so if you want to make it non-tunable, you just do the same thing again, it becomes black. Now what happens is in LNS parameters, you have few curves. One is is what we call the noise figure, the blue curve in here, and the purple one is called the S21, that's the gain of the LNA, and then the brown and the red are the S11, S22. S11 is that input, the return loss. The brown one is the input return loss. The red one is the output return loss. So this, you'll see few markers. This is coming from the optimizer goals, and it says basically the same things that's given to you. So it's operating frequency 18 to 22. So this is for the question 3, and the gain is 20 dB minimum. Return loss has to be greater than 10 dB, and noise figure has to be less than 1.5 dB. So you need to tune LNA, different parameters. You need to get a feel for it to tune, and then tune it such that gain is above this value, noise figure is below that value, S1 and S22 is below that value. So in the band of interest, red and brown curve should be below, and then this purple curve should be above, and the blue curve should be below this. I think I just noticed another error. This purple should be in the optimizer goal. If I go to S21, so measurement has to be greater than, so you notice this flips over. So that flips over, that's how it should be. So you can correct it in your projects too. So that's what you need to. So how do you tune it? You go to this tuning tool and you get a lot of parameters. Some they will show input match, intermediate match, output match. So if you change things in the input match, you can tune this. So things change slightly. It's probably not very critical, that parameter. Like what if you change the inductor? So you'll see when you change the inductor, it moves. So basically you need to tune it such that it comes close to, basically you need to tune the parameters in the input match, output match, intermediate match, so that it meets all these specifications. So that's your task. Okay, so that's a bit of playing around. Now the S1 and S22 like this can't go up. That's a problem if it goes up. The S1 S2 has to be always below 0. So if you have some things like that, that's not allowed. Okay, so you need to make sure that doesn't happen. So basically you'll get 3 marks for that exercise. So you'll have to spend a bit of time on this. On 3 marks, if you meet all the specs, you get 3 marks. If you meet maybe say 50%, you get maybe 50%, you'll get 1 mark, and then somewhere in between you get 2 marks, right? So that's what you need to do for task 1. So it will take some time, especially for question 3. So you need to try it. That's what you need to also do in your project that you have to do semester wide. So this is important. So task 2 is to answer the questions. So that's straightforward. You just have to answer your questions. So that's a brief introduction on the lab. Hope this helps. And yeah, we'll see you in the lab. Thanks.